Hey, welcome everyone. If you want to become an exceptional tech recruiter in today's market and you're new to this whole arena, then you are in the right place. This is essentially the first video you need to watch. Here we're going to cover 50 fundamental IT principles and concepts which will rapidly bring you up to speed and show you how to speak with passion and confidence with anyone from the tech recruitment process. So you'll better understand tech CVs, you'll speak with more credibility with IT candidates, and you'll just come across much more professionally with IT clients as well. My name is Ayub Shaikh. I created the world's first Tech Recruitment Training Academy over 24 years ago, and since then I've trained tens of thousands of novice tech recruiters just like you to stand out in this industry. I'm an award-winning trainer, author of the IT Recruitment Survival Guide. My training's been used on the LinkedIn Learning Library, and now we're bringing our content to YouTube, obviously. And today, here and now, I'm about to hold your hand and guide you swiftly through this whole landscape of tech recruitment so it doesn't appear so daunting for you. Ideally, so that you can engage with the same passion and enthusiasm as me. I've done it for others, so let's do it for you. This whole area is huge. And so, of course, this is quite a lengthy video, so you're going to want to take notes. But remember, we do have the largest resource library in the world for tech recruiters, which we've built up over 24 years. So you'll want to jump in and tap into all the good free stuff there. But without further ado, let's dive into the first topic now. Okay, so the very first thing that I want to cover is weirdly something that no one else seems to go over in the whole of YouTube, and that is how to visualize IT in simple terms so that you, as someone who has just transitioned over from pharmaceutical, or you may just be completely new to recruitment, but if you've come over for pharmaceutical, accountancy, or something else and you just don't understand tech, well then of course what you need is this amazing model. A simple model for you to understand. And that's where I'm going to go first. You cannot understand tech recruitment or technology if you don't understand the DNA of tech. And that is what is really the first thing that I teach all my students when they come on my courses. And that's what I'm about to do now. So how do you visualize IT? Well, how comforting, firstly. How comforting to know that there is a model. A model exists that allows you to quickly visualize whatever you have in front of you, whether it's a smartphone, whether it's a supercomputer, whether you're going into a client who is a global bank. First thing you really need to understand is to bring it right down to fundamental principles. So that is step one. Lay the groundwork, and the groundwork model for this is here. So there we go. It's a 3-layer model, and that essentially is what IT is. IT in all its guises, whether it's nanotech, a smart contact lens, a smartphone, or a supercomputer, at the end of the day, IT must always be defined in these 3 layers. And the first thing you need to understand is the concept of hardware. Now, most people, of course, are very familiar with this concept. When you walk into a shop and you're buying your computer, when you're buying your laptop, you know that you're looking at the physical entity. So IT has this physical layer, and hardware is, of course, how we describe that layer. Now, weirdly, over the years, when I started this 20 years ago, hardware was a very boring concept, of course. It just consisted of a PC that's sat on your desk and some large machine called a server or a mainframe somewhere else. However, hardware has now become such a cool concept. As you can see, hardware is rapidly evolving into smarter and more interesting devices around us. And it's actually rapidly evolving into taking over our lives. So we have smart fridges, we have watches, we have so many things in our lives that are becoming more and more tech ready. And so this concept of hardware is an interesting one, but we'll go into that in detail on another video. But the first thing you need to understand is that all IT has hardware. Now, to make that hardware work, there is a layer of software that needs to be put on. And that's the key thing. So essentially, there are 2 big families of software that sit on top of our hardware, as you can see. And the first software that you put in any IT infrastructure is what's known as an operating system. So an operating system is what brings your hardware to life. And that's essentially the function of something like Windows or iOS or Android. You put them onto the hardware and it brings your hardware to life, and it allows you to get it ready for the final layer of software, which is application software. Now, you and I, and larger organizations, indeed your clients, won't really be necessarily interested in the operating system. We're much more excited about the applications in our life. So where hardware is made usable by this software called operating systems, applications are the useful things in our life. So essentially, Microsoft Word, Instagram, Google browser, they're all applications, but they cannot work without an operating system in the middle. Now, here's the key model, and I spend quite a lot of time in some of my training going over this so that you fully understand it and the implications of understanding this. So when you walk into a client site and they're using Linux on IBM with a risk management system on the top, you would speak in a certain way. There's a certain level of candidates that they need. However, when you walk into a client site and they're using Windows and off-the-shelf Windows software at the top, well, there's an implication to that as well. So in my other training videos, you'll come to realize that actually the nature or the makeup of the client and the operating systems and the hardware and the applications that are mentioned on job specs and resumes will dictate how you speak to the candidate and how you speak to that client. So this is almost the key to conversation. Now, more on that later on. Today, we're just looking at the fundamentals. So first thing, make sure you understand that there are levels of hardware, operating systems, and applications. So now that we have that three-layer model, it's worth diving deeper into this. And this is where I want you to get used to some of the terminology linked to all of these layers. And of course, then we're going to expand it beyond that to some of the heavier stuff. But for now, let's just make sure that you've got the fundamentals in place. So as I said, you think of the hardware as the physical stuff. You can touch it. It makes you, it's your IT system. And essentially, it's like the foundation of your house. But terms relating to hardware, they come in big and small sizes. So when you hear terms like mainframe, this is a type of hardware. It goes way back to the dawn of IT. But essentially when people say server, they essentially mean these large machines. And if you've got any large clients, then the likelihood is if they own their own hardware, and if they're storing all their information and processing it themselves, they are using mainframes. But don't forget that even in large data centers, they also will be storing data, processing data for their clients on these large machines. So here is the first type of hardware that we should know about, the mainframe. And generally when people say servers, they mean mainframes. Now, there is also, of course, the hardware that you use at your end. In networking terms, a mainframe or a server is there to connect to you, the user, at your end. So on your desk, you will have a laptop, you will have a PC, occasionally you might have a Mac, but generally in large banking environments or in large corporations like a pharmaceutical company, they probably won't use something like Apple. They will probably use PC-based environments. So essentially, the user machine is often known as a desktop machine or a PC. But I want you to come to terms with another concept here, that in IT, in networking, when we think about hardware, we often use the term client-server architecture. Client-server architecture. And what that essentially means for a networking person is the client is you at your end and your machine. So your client could be your phone, your laptop, your PC. When things get wrong, go wrong in your architecture and you phone up support, they don't say, oh, so-and-so's PC has gone down. They will look at the network and they will say, our client 559 has just gone down. So your machine to them is the client, and it is connected to the server. So client-server architecture is a huge concept within networking, and generally it's how most organizations work. You at the user end connected to some server somewhere. Now, even if that server is not in your building and it's in a different building, indeed another country, indeed in the cloud, it still remains a client-server environment. So that's another term you need to know. Client-server networking is all the rage. Now, we've mentioned terms like server, but of course, many years ago, we flipped over from the idea of owning servers and buying your own mainframes. But of course, when I started out in recruitment, many companies did buy their own architecture. They had their own mainframes downstairs in the basement, and you as the user would be using it upstairs. So your applications would be stored on that machine downstairs. However, of course, that was expensive. Servers became outdated very quickly. And so this was a very expensive way to operate. And people realized this quite quickly, of course, as we entered this whole era of cloud. And so when people talk about a serverless architecture, it means that there is no server in essence, not for you. It's managed somewhere else because you don't manage it directly. And there are lots of terms in hardware that means serverless. So serverless essentially means you have got rid of this responsibility of looking after your own mainframe. Why would you go out and buy this very expensive equipment when others can look after that equipment for you and just maintain it and upgrade it and get the latest machines? So when they talk about serverless architecture, it simply means you are connected, but you're connected to somewhere where you do not hold the responsibility of looking after it. Someone else is doing that for you. And of course, another term that kind of implies this in cloud terms is IaaS. So we're still sticking to this whole area of hardware, and we're thinking about infrastructure as a service. So quick tip here, of course, whenever you see the term IaaS anywhere, it always means cloud technology. The most common one you're going to come across, of course, is software as a service, SaaS. But in the context of hardware, it is infrastructure as a service. And in essence, this is like instead of buying your own kitchen, you can actually rent it a fully stocked kitchen from a provider, and they will give you all the tools and all the latest technology, and you can just use it based on a timely use. So they will charge you for the time. And that is what cloud facilities are. Everything as a service, it is billed per time, per storage, per processing. So essentially, you don't have to pay for the whole thing, the outlay, you just use it for the period of time that you're using it. So you just pay for the period of time you're using it. And that is infrastructure as a service means you don't have to go out and buy your expensive architecture. Someone will look after it for you. Now, let's not forget when we're staying in this whole area of hardware that there is networking hardware between the client and the server. And these are the little things that connect everything together. These are essentially like the roads and the highways of your network. But in between, you will have devices like routers and switches, and they're effectively like traffic controllers directing the data between you and the server, or indeed you and the internet as it is going out into the wider world. So lots of information there. We've got an entire course on recruiting networking people, of course, but that's a different video. Here, we're sticking to the fundamentals. I'm just introducing those concepts to you now. We're still staying with hardware. Should I go here? Yeah, I think I should, because there is actually a cool area of hardware, which is a very niche area of recruitment, but a lot of you may get involved in real-time embedded systems recruitment. So essentially, this is where we are talking about systems where the hardware doesn't really look like a computer at all. These are your gadgets that you will use. So essentially, real-time embedded systems is where IT and engineering overlap. So when you think about automotive engineering, when you're thinking about your fridge, when you're thinking about your air conditioning system, your microchips in your phone, anything where the hardware has software embedded into it is this niche area. And it's all around us. We're talking about fighter jet planes, missile systems, microwave ovens. This is the realm of real-time embedded hardware. So again, I've got training on that, but I just want you to know when anybody mentions real-time embedded systems, they are really entering the area where IT and engineering come together. And this whole area of IoT, Internet of Things, essentially is real-time embedded systems. So what is the Internet of Things? Yes, it's another hardware concept in essence, because it is whenever traditionally non-IT devices have become internet ready. We didn't have fridges that were internet ready in the past. We do now. Our switches and our air conditioning systems and our washing machines and our toasters are all becoming internet ready. And essentially that whole area is known as Internet of Things. So whenever anybody mentions IoT, it means traditionally non-IT things that are becoming internet ready. And that's a very, very cool area indeed to recruit for. But that goes hand in hand very often with chip technology and real-time embedded systems. As I said, again, huge area of recruitment. We have training on it, and you can delve into that in another video. But that's what you need to understand about hardware. So there's a huge spectrum of hardware. I'm not going to go into all of those tiny concepts here, but it's to introduce you to the idea that hardware is cooler than you might think. It's not just the laptop or the smartphone that you walk around with. There is so much more to hardware, especially when you're in tech recruitment. You've got to think on a bigger scale. Your companies are much more excited about the big stuff at the back end that is pumping data and processing applications for you at the front end. So banks, large organizations will always be concerned with how to keep that running perfectly. And so when they're looking at Linux administrators, Windows administrators, they are looking for the very people who will look after the health of that hardware and that network. So that's layer one in our 3-layer model, hardware out of the way. Now let's dive into the second layer. So we're thinking now about these top 2 layers, and it is software that we need to think about. So of course, this second layer is known as an operating system. Now, your phone, your laptop, your tablet, they all run operating systems. And these are terms that you will have come across, but you wouldn't have understood the significance of them. iOS, it's huge. Your phone cannot run without iOS, okay? Android, Windows, these are the effectively nervous systems of your devices. Without those, you couldn't put all the good stuff, all right? So essentially, these are like the conductor of an orchestra. Operating systems manage everything within your hardware, and they look after security as well within your hardware, and more importantly, they bring they create an environment that will allow you to bring applications on. So operating systems are huge. So you're thinking about Microsoft Windows, you're thinking about Linux, you're thinking about iOS, you're thinking about Android. And we'll delve into these in much more detail in another video. But operating systems, get your hardware ready for use. Now, finally, in this area, of course, that top layer is application software. So these are the apps or the programs you use every day, like Microsoft Word, Spotify, Instagram. They are the useful things that you and I really are far more interested in. We don't really care what's going on in the background with your operating system, but we really are excited about new applications in our life. And so we use them for work, we use them for pleasure, we use them to just basically run our lives. Application software are the things on your device that allow your device to become useful. Operating systems make them usable, but applications make them useful. Now, an important concept within this whole area of software is that you need to understand that you generally buy software that is what we call OTS, or off the shelf. Okay, now you can think of this as basically everything fully done for you. It's ready to go. There's no customization that is needed. It's like going into a supermarket and buying an off-the-shelf frozen pizza. Essentially, that is what you and I do when we buy applications. But large organizations, they can't all just go in and buy off-the-shelf applications. Of course not. Think about it. A bank cannot trade with off-the-shelf software, because if all the banks use off-the-shelf software, then everybody would be trading at exactly the same pace, because the software would work exactly the same. No, the way you get ahead in business is by tweaking the software or even building it yourself so that you can be faster than the next guy. I hope that makes sense. So your organizations, they use developers to develop their own software, or they may have something that's in between. So there is another thing down the spectrum from off-the-shelf software, and that is commercial off-the-shelf. So this is like software you and I use, but of course it's much more commercial, and it can be tuned to what the client actually wants as well. Now, coming further down into that spectrum, well, essentially then it's completely bespoke software that the client has built from scratch, and that's where they would need programmers or developers to make sure they can build this software. Usually though, nowadays, your companies, your IT clients will go out and try and buy something that can be semi-customized. So something like Salesforce can be bought in, but it will be tuned and customized to the client's need. And so very often that will be the case because it's proven software. When you try and build things from scratch using just the programming language, well, of course, you are actually working with the raw product, untested. Whereas if you buy things that are tried and tested, the likelihood is they're going to be much more robust. Another and maybe final concept in terms of software is this whole area of ERP, Enterprise Resource Planning. Now, this is a beautiful area of software. It is application software, but this is software designed specifically to make large organizations unified in the way they use their software. So essentially, in large organizations, think about it, large companies that are maybe very often global companies, they didn't just pop out like that and just they weren't formed like that from the very beginning. They would have grown over time, organically. They may have been takeovers and mergers over the decades that this company has come into existence. Now, over that period of time, what happens is they will, of course, buy different software to try and test and use. And of course, different cultures and different countries may be using different software, maybe to even do the same thing. So it could be that the accounting system for this company in Brazil is going to be different from the accounting system in the UK. Now, they could be two different vendors, two completely different applications for that accounting function. Now, very often this leads to a mess within large organizations, because when you send records and data between these different software, it becomes a nightmare to try and make that work. That is what ERP does. Enterprise Resource Planning is essentially like a software that overlays itself and becomes essentially like a glue that connects all of the different enterprise softwares together. So essentially you will see terms like SAP, Oracle, these are ERP systems, and it's always huge. An ERP implementation in your client means they are undergoing a major implementation and a change of culture within the organization. So ERP systems bring all the others together to work, ideally, seamlessly. Not always the case, but ideally, that's what ERP systems are designed to do. I may just move forward into a few more techie concepts here before we move away from software, I think. So As you're going to be dealing with the channel and as you're going to be looking into tech recruitment in more detail, of course, we want to bring you right up to speed and just make sure that you understand some of the more radical and newer concepts that are being used, but they're using them furiously around the world. These are software concepts, but you will come across terms like microservices architecture. Now, microservices, you've got to understand that as we move into the future, a lot of the things that you need in applications have already been made. So why would you reinvent the wheel? And in fact, it's a bit like designing a new car. So when you're a company like Audi, Volkswagen, and you're creating a new vehicle, well, you don't start from scratch every time. Over the 100 years of your existence, you'll have created loads of gearboxes and loads of different elements of that car. Engines, cogs, gearboxes, there's so many things that you have. In software development now, the whole idea is of reusing code. And that's important for you to understand. That very seldom do people start coding from scratch. Nowadays, they use code in a very reusable way. They know where to go to get those. And they use libraries. I'm introducing these concepts now. I'll cover that again later on in the video. But they use libraries and essentially they use containers. So whenever you see terms like containerization and libraries and frameworks, it is this idea of reusing code again and again. And one of the terms that you'll come across is microservices. So microservices architecture works in this way as well. Microservices are like small pieces of code, and they all work independently from each other, and you can use them within your new application. Now, there are a few things that you will come across that essentially replicate this concept. Now, I'm not going to go into that here, but it's to let you know that when you see terms like object-oriented programming, that is creating little objects which you reuse again and again. Microservices, again and again. Scripting are small pieces of code, a script that you can reuse again and again. So for example, on a website, a clock can be a script. A drop-down menu can be a script. So you'll come across these terms like scripts, object-oriented services, microservices architecture. And essentially all of those are about the reusability of code. Now, again, I'm not going to go mad here about this, but I just want to introduce you to this idea that there is microservices and reusability and object orientation within this whole area of software application. So that was application software, and that was the 3-layer model. So I just want to make sure that you understand that is essentially a good way of visualizing anything in IT. Think of it as a 3-layer model. If I pick up your phone, I know it's a 3-layer model. It's iPhone, iOS apps. It's Samsung, Android apps. If I walk into a client site, I know that they're using Z series, Linux or ZOS, risk management system. If I walk into a printing company, it's Mac, macOS, Photoshop. The 3-layer model always works. And so this is a good way to start your understanding of tech, understanding that all tech, IT, has hardware, operating systems, and application software.